Assalamualaikum warahmatullahi wabarakatuh. Good day, ladies and gentlemen. Thank you for coming to my presentation today. I am glad to meet you all. Before starting our presentation today, let me introduce myself. I am Nenden and my partner Vita and Nurfida. And we are from Indraprastha PGRI University, Jakarta, Indonesia. Well, in this presentation, we are going to discuss about morphology study of agave fiber surface by using scanning electron microscopy. First, I will explain to you about the background of this research. That is, agave plant can grow well in all weather conditions. So, they are very abundant in Indonesia. Of course, a method is needed to develop the utilization of agave plant to have a higher value. The objection of this research are engineering material from the Agave americana plant by providing alkaline treatment to agave fiber, and investigating the surface morphology of Agave americana fiber using SEM or scanning electron microscopy. In this experimental, the sample was divided into two types, namely the normal sample as a control without being given any treatment, or we call untreatment sample. Then the second, the sample soaked in alkaline and called the alkaline treatment sample. The parameters observed were the surface morphology of the fiber, which was analyzed by using SEM at magnification of 250 times, 500 times, and 1000 times. In this section, we can see that untreatment process of Agave americana. Agave fiber sample derived from the Agave americana plant. The leaves were cut, then the spine of the edge were removed. Furthermore, the leaves of the agave plant were dried in direct sunlight for 2 days to remove excess shade. The next process, the agave fiber was soaked with water for 2 weeks, and after that, the agave leaves were combed to separate the fiber. The separate fiber were allowed to dry at room temperature and ready to be characterized. Which is the treatment process of Agave americana? Agave plant that have been cut from tree were cleaned of dirt and direct at room temperature for 2 days. And then the leaf of agave plant were cut into pitch 15 cm by 3 cm in size. Then soak with 5% alkaline sodium hydroxide solution for 30 minutes. Then wash with dilute hydroxychloric acid to remove excess alkaline. Next, the fiber were rinsed with cold water 2 or 3 times. After rinsing, the fiber were dried at room temperature for 2 until 3 days. Ultimately, the sample was ready to be characterization by using SEM. Let us continue to the next slide. Measurements were carried out using the Hitachi S3400 and scanning electron microscope. Like this picture, agave fiber SEM image were analyzing by using imaging application. And then the analysis result was represented in the form of a histogram with pixel average value and standard deviation. Next, result and discussion. The following is an image of the result of characterization using SEM untreatment fiber and treatment fiber at magnification 250 times, 50 times, and 1000 times. In figure A, C, and E, it was visible that there was less adhesion matrix. This indicated a weak intermatricial adhesion attraction. This condition caused agave fiber composite that are not treated with alkaline immersion to be more brittle. The presence of wider cavity also indicates that the adhesion rate between the fiber and matrix is also low. In figure B of the agave fiber treated by immersion in 5% alkaline sodium hydroxide solution, fewer cavities were observed, and the fiber was appeared to be chemically bonded to the matrix. This is what makes the agave fiber composite soaking with alkaline has higher strength. And we can see at figure D and F that the fiber was appeared to be chemically bonded to the matrix. This is what makes the agave fiber composite soaking with alkali has a higher strength. The fiber also was appeared to be evenly distributed on the composite surface. In technical application of nature composite, the structure of agave fiber could affect the mechanical strength. So, based on the surface structure, immersion treatment with 5% alkaline sodium hydroxide qualitatively could increase the strength of agave fiber. And next slide. At higher magnification, example given at 500 times, it can be seen that the agave untreatment fiber, like figure A, have a raw surface than the agave treatment fiber, like figure B. Quantitatively, the magnitude of the increase in the strength of agave fiber can be seen in the histogram of figure C and D. From figure C, it can be seen that the agave fiber in untreatment group has a curve with dominant shift to the left, shift to black color. The average pixel value of the agave untreatment fiber was 90,016 pixels, with standard deviation value of 26,783 pixels. At high standard deviation indicates that the cavity on the surface of the untreatment fiber has a wider spread area. The percentage intensity of the shock can be calculated by determining the standard deviation ratio and the average pixel value. The intensity percentage of the untreatment fiber cavity was 29.754%. And we can see at figure D, agave fiber that treat with alkaline immersion has a histogram that was in the more right area compared to the histogram of control agave fiber. From figure D, it can be seen that the histogram was sharp with an average pixel value of 108,034 and a standard deviation of 9,489 pixels. The low standard deviation of agave treatment fiber also indicated that the surface of agave fiber was more homogeneous. The percentage of pixel intensity was 8.783%. The immersion of agave fiber with 5% alkaline sodium hydroxide caused the pixel cavity in the fiber to decrease significantly. The lower percentage of cavity in treated agave fiber was also due to the low lignin and cellulose content in the fiber. So that is all my presentation. In conclusion, we can say that the immersion treatment of agave fiber with 5% alkaline sodium hydroxide made the morphology of agave fiber more homogeneous. And in addition, immersion with 5% alkaline sodium hydroxide also caused a significant decrease in the percentage of cavity intensity. This condition made the fiber bond with the matrix in the agave fiber with alkaline treatment become stronger. Thank you for listening. May all those we have shared be beneficial for all of us. Assalamualaikum warahmatullahi wabarakatuh.